Okay, next I want to take a very quick look at a particular function that we call the greatest integer function. And I want to look at this because the majority of functions that we're going to deal with in this course, their rule is defined by some equation relating x and f of x. But remember, function rules don't have to be defined in that way. Functions can act on any type of object, and their rules can be defined any way we choose. It's just in particular we focus on the functions whose rule is given by an equation. But the function I'm going to look at here is called the greatest integer function, and the notation for that is this double bracket around a number. And what this means is we want to take the greatest integer less than or equal to that number. So an integer is just a whole number, it can be positive or negative. So we're looking for the largest number that is less than or equal to the number in the brackets. So as a couple quick examples, greatest integer for 2.8 would be 2. 2 is the largest integer less than or equal to 2.8. For pi, this would be 3. Since pi is roughly 3.14, 3 is the largest integer less than or equal to pi. The greatest integer function for 7 would give us 7. That is the largest integer less than or equal to 7. And for negative 1.5, it's actually going to be negative 2. So basically this function is rounding down, but when we're looking at negative numbers, we have to be a little careful. Negative 1.5 wouldn't go to negative 1, it would have to go down to negative 2. That's the largest integer less than or equal to negative 1.5. And this may seem like a really weird random type of function, but as sort of a silly application of it, when you are asked your age, you actually respond by taking your true age and running it through this function. For example, if somebody asks your age, you don't say that you're 20 years, 8 months, 7 days, 4 hours, 3 minutes old or whatever. You would just say, I'm 20. You're rounding down to the closest year. Okay, now suppose we wanted to sketch the graph of the greatest integer function. So the greatest integer function is actually a piecewise defined function, where its rule changes based on the input for x, and in each case, it yields a constant. So just let me get my coordinate system here, and what I mean by that is, let's say if x is between 0 and 1. Okay, so if x is less than or equal to 0 and less than 1, then our greatest integer function for x is going to send us to 0. Right, so if x is 0 or 0.1 or 0.2 or 0.3 and so on, all the way up to 0.99999, this would always get sent back to 0. And if x is greater than or equal to 1 but less than 2, then the greatest integer function for, for x rather, would send us down to 1 as the largest integer less than or equal to x in that case. So this would be for x is 1, x is 1.1, x is 1.2, x is 1.3, and so on. Okay, if x is greater than or equal to 2 but less than 3, greatest integer for x would send us down to 2. And so forth. And just to take a look at some negatives, let's say x is greater than or equal to negative 1 but less than 0, then greatest integer for x is going to send us down to negative 1. So what does that look like as far as the graph is concerned? So from x is 0 to 1, so that would be this little region here, the height of the graph is 0. So let me go ahead and fill that in. From 0 to here, the height of the graph is 0, but at 1, it actually jumps up to 1 here. And then it stays 1 until we get to 2, and then it jumps up to 2. And then it stays at 2 until we get to 3, and then it jumps up to 3. Now, those open circles that we've talked about with piecewise defined functions, they sort of close the one graph that we're drawing before we jump up to the next one. So at, 4, we jump up to 4, and so forth. At 5, we jump up. And the same thing's happening on the negative portion of the axis. So from negative 2 to negative 1, from negative 3 to 2, and so forth. So each one of these little steps is the graph of one of these intervals. And functions like this are called step functions because when we graph them, we get what looks like a set of stairs. So just a quick little look at, again, just to emphasize, functions don't necessarily have to just follow a nice equation like f of x is 3x minus 5 or something like that. We can define a function any way we want. We could define a function, verbally. There's not really a way to write this as an equation, right? We said the greatest integer function of x is the greatest integer less than or equal to x. That was written out verbally. You could write this as a really long piecewise defined function, but there's not a nice simple way to write it as an equation or a formula. And again, just to see what the graph of one of these weird functions looks like.